Hello everyone, good morning. I'm Shravani Kale. I'm doing my PhD from Defense Institute of Advanced Technology under the guidance of Professor Sangeeta Kale. Today I'm presenting on resonance-based sensor for detection of nitrogen oxide polluted water in industrial effluents. So basically here for the sensing purpose, we are going to use metamaterial inspired CSRR. So what are metamaterials? Metamaterials are nothing but periodic arrangement of elements or structure whose size is much smaller than the incident wavelength. And because of these, it possesses very unique properties like negative permittivity, permeability, and their frequency, resonant frequency depends upon the structure and size. So using this, we have developed CSRR, complementary split ring resonator. The difference between split ring resonator SRR and CSRR is SRR is excited through magnetic field while CSRR is excited through electric field. Obviously, CSRR are used for this application for sensing application because of the rapid detection, miniaturized device, highly sensitive, and so on. So, figure 1 is showing CSRR structure and its equivalent circuit model. So, basically, CSRR is kind of like first we will have a plane which is a conducting plane, which is called as ground plane. Then, in between, there will be a substrate which is a dielectric. In our case, it is FR4. And again, at the bottom, we will have a transmission line, microstrip line, which is again conducting. So, in our case, the conducting plane is of copper. So it is like ground plane, substrate, and microstrip line. On the ground plane, we have this structure where you can see two square loops. So this is total CSRR is its electric equivalent is nothing but a LC circuit. We can see that the gap between those squares, it will kind of provide you LT inductance. Again, those between those islands, there is a gap between two conducting islands. We have that gap which is providing us a capacitor. In a similar way, the microstrip line acts as an adding equivalent capacitance. So this total circuit is kind of a LC circuit, and its resonant frequency is given by FR is equal to 1 by 2 pi under root of L effective C effective. Now, when we talk about the sensing with CSRR, what we will do is we will add a sensing material on the top of CSRR. So the directly only CSRR cannot detect gas or anything because they are not active material. So for that we will need a nanomaterial. So using nanomaterials, what will happen? The properties here we are using the material as Ti3C2TX and Fe3O4, that is magazine and Fe3O4 combination, and the C effective will now change, which will be dependent upon the dielectric of the sample, because as we all know, capacitance is equal to epsilon A by D. So as our dielectric of the sample will change, basically the C effective value will change and the resonant frequency will shift. This is how we are going to sense. These are the parameters for the sensing, not a sensing for our. So basically, CST Microwave Studio was used for the purpose of all the simulation, and these are the simulation parameters. So here, as I said, we are using copper and FR4 for CSRR and the nanoparticles. Nanoparticles basically will help us in the selectivity and specificity because they will enhance the our sensing. So little bit about our material. I'm using magazine. So magazine is Mn1, its general formula is Mn1 plus XNTX, where M represents transition metals and X stands for carbide or nitrides. So in our case, we are using titanium carbide Ti3C2TX, where TX represent the surface termination group, which are O, OH, and F. So magazine is kind of 2D structure, which is a very porous, so high surface area, and also because of this surface termination group, that will interact with the gaseous molecule, and because of this, magazine is ideal for gas sensing. Magazine is a new area in this 2D world, and it is used for different applications like electrochemical, gas sensing, terahertz sensors, etc. It is very high conducting, highly conducting. So that's why we are using magazine to provide a high surface area along with Fe3O4, because Fe3O4 will help us in the giving electron to transit NO2 to NO3 minus. So this was the methodology for preparing the in situ combination of magazine plus Fe3O4, where two solution was prepared. First one using FeSO4 and DI water. Second was using ammonia and DI water. To this solution, then the prepared magazine, which was prepared using HF etching method, where max is our parent material, and through that max using HF etching, we have removed the Al and make it porous structure. And using this, we have prepared the magazine. This magazine were added under the argon pressure, and the whole the procedure was followed. This is the characterization of the synthesized material. Here in the Oxide, you can see peaks present of both Ti3C2TX plus Fe3O4. The peaks present at 9.2 and 27.8 represents magazine structure of 002 and 008 plane, where the other peaks denotes Fe3O4 structure. We can see here from the XRD also the broadening of the peak of Fe3O4 suggesting nanoparticle, and which can be clearly seen in FESM images. So this was experimental setup where we have a NO2 gas generator. From that, so this prepared powder of magazine Fe3O4, the certain amount of powder was taken in a pint of tube of, and there was 1 ml of DI water was added to this solution of DI water and nanoparticles. We are now purging the gas, and this gas is now we will broadcast in on our CSRR a very small quantity, 200 microliter of this solution will be broadcasted on CSRR, and using VNA vector network analyzer, we will see the shift in resonant frequencies. So this is how the NO2 gas purging time and NO2 with the help of NO2 gas purging time, we calculated the NO2 gas concentration, because our instrument gives 10.59 ppm per minute. So that's how we calculated. This is showing the NO2 gas interaction with our material using FTIR. So red plot shows, red graph shows without NO2 gas purging, and black one is showing with NO2 gas purging. Here we can see two main things, that the first one, which is in insect, that there is introduction of one peak which is at 1347 centimeter inverse, which is indicating the involvement of NO3 minus. So this suggests that NO2 is attracting electron from our material, and it is interacting with our material. Also, the shift in ATO staging from 562 to 528, this is again suggesting that the sensing has been done. And